Hey, what's up everybody? Welcome back to another layer by layer tutorial. In last week's tutorial, I showed you guys how I put together this parametric design for these arcade buttons and an Adafruit Feather M0 Express. A couple people have asked me how I would make the bottom part of the enclosure so that it snap fits, so that you have nubs and indentations on the two parts. So I went ahead and tried that out, and I also did a couple of improvements as well to it. So let's kind of walk through the demo now. So the first visual thing is, of course, there's a bottom now. There are snap fit nubs. There are kind of strategically placed around so that they're not intersecting with the featherboard. We'll take a look at that in a little bit. I also added the components for the arcade button. So this is really cool. So if I do change parameters and I want to update this, let's say I want 3 across and 2 down, I'll hit enter by updating the expression. And now you can see that what happened here was we got more arcade buttons, and if I hide the parts, you can see that the holes I've retained, they're in the right spot. And now we have the Adafruit featherboard here, and that has updated as well. So when I put this back to 2, keep your eye on the featherboard, and you'll notice that, well, it moves along with the design. It's actually centered, and it'll always stay centered with the design. So it's pretty cool. So you can make some pretty neat things. I could even say 1 across, 2 down, and it still works. It's just anything smaller than that, it probably wouldn't work. So pretty neat. You can kind of see through the case and see that there's these little nubs with proper clearances and things for tolerances. So that works out really well. I'm gonna set this back to 2 by 2. Okay, so that's just a quick demo. And the next thing we'll do is just kind of step through the design and kind of walk through it so that we can make the bottom part. So let's take a little bit close look at the bottom part itself. I'm gonna go ahead and hide the box and just take a look at the bottom. It looks very similar to some other enclosures that I've done before. You can notice that there is a lip, and in certain areas in the lip is an indentation going inward. So you can see that this is, for example, this edge here is being extruded inward to accommodate for this cut here that is for the nub. So we have 1 here, 1 on this side, 2 on the back, and 2 in the front. You also notice that there is an opening here in the lip to accommodate for, well, the feather board. If I were to have just 1 nub going across this whole lip, these two faces, this face right here would intersect with the standoffs and push the thing back. Now, the reason why I have the feather so close to the edge is, well, for a USB cable. We could push the feather back, but I like to have it as close as possible to this surface here of the enclosure so that we don't have to embed our USB cable so far into the enclosure. So that's why I have that opening there. And I'm starting to kind of do that with more in projects going forward. So it was really kind of interesting how that is built. So let's take a look now at kind of step all the way back. I'm going to roll all the way back to the very first thing. The very first thing I did was I made, of course, the component for the case. Since I was gonna plan for integrating the actual components into this, not just the case, but the components being the feather and the arcade buttons, I needed to create another component, because if I do, let's say 8 by 8 buttons, I'm gonna have 64 buttons, and it's nice to have them all enclosed in its own component, so I can hide them, move them, do all whatever I want. So that's why I have 2. The next thing I did was I actually imported the arcade button. So the arcade button is a standalone, separate design. It was put together like this. One thing really important to note here is that the way this arcade button was made, if we go to the very first sketch, you'll see it's smack dab in the middle, in between the X and the Y axis. So this is built super in the middle, just like our button box is designed from the center. So is this. This is also designed to center. It's very important to note that, because if it was built somewhere else over here, for example, where my mouse is, or over here, the design wouldn't quite line up. So that's why I have this in the center. So just keep that in mind. So when I imported it in, it is exactly in the spot, kind of exactly in the spot where I want. I did have to do one update, and that's where I just moved it up in the Z, because the way the enclosure works is, since I'm extruding the enclosure from the bottom of the grid, I'm going up. So I have to move this guy before I do anything. So I moved it up. One thing to note about the capture position, it's the move command itself isn't really that parametric. So if I double clicked on the capture position, Now I'm inside of it. I can move it around. I don't have any options to modify anything, just the movement in the line tool. So I can still move it. And that's really what it's doing with components, is when you move your component, it's very important that you capture its position so that Fusion knows it snapshots its position. Problem with that is, though, I don't have any ability to tell where it originally was, other than this first link here. So when I hit the move command as it's selected, you can see that all this is zeroed out. So if I were to move this around and hit OK, go back into the capture position, hit move, all this would be zeroed out because it just kind of zeroes out itself. So just kind of a side note, important to know that wherever you move this really doesn't retain any XYZ axis things yet. So I'm going to hit cancel on that. So I captured that position. Whenever you move a component, you get this guy up here. It says capture position or revert. This only shows up whenever Fusion sees that a component was moved. In this case, I just clicked and dragged it around. So I'm going to hit revert, and that'll put it back where it was. So the next thing I did was I ran a pattern on this. So I clicked on that, and then I said rectangular pattern. So I ran that pattern and then basically made a 2x2 button. Now it's a little weird right now. It's just one of the behaviors. I'm going to go into it, hit OK, and then it just updates. It was reminiscent because I was changing the button, so it's fine. It didn't break anything. So I'm going to go back into it actually and show you how it's working. So you can patternize component. So the pattern type is set to component. My object was this very first one. The direction is, it could either be the X or the Y axis. Doesn't really matter, but I have it set to, you can kind of see it here. This line here is just the origin here. So I turned on the origin and I selected that little red arrow there, which is a reference point for the X axis. So that is the direction that it's going in. Then I changed the distance type from extent to spacing because I want to have spacing. Then what I do is I have the quantity for the first round be across, and then the distance is spacing because I have a parameter set for both of these, right? So right now it's set to 2 across, and the spacing I believe is like 30 millimeters or so. We can change that, so that's what that's set. And then for the second quantity, I have it set to down. So this is controlling the down. And then take a look at this, it's actually negative spacing. So if you ever need the direction to go kind of the opposite way, by default it's going up this way, but I needed it to go down the other way. So I just put a negative there, and Fusion is smart enough to go, oh, okay, just go negative on that way. So that's how that's being made. You may or may not need to do that, but that's an option that you can add if you need it. So once that was done, I have my patternized thing. I can test it out. So I can go to change parameters. I can say maybe I want 3 across and 3 down. You can see it updating, and all of these components are being duplicated. And it's nice that they're inside of a parts component so that they're all nicely collapsible. So I'm going to go back to 2x2 because it'll just make things easier. And I'll just leave everything else. I hit OK. So that's how I created those. I kind of imported these first and then made our enclosure. So now I'm going to go ahead and step into the next thing. Now with the case component activated, I went ahead and created my first sketch, which was the circle for doing the cut. So if you remember in the last week's tutorial, this is actually where I started. I started with the cut first, and you'll notice that it's in the exact dab center of our grid. So right in the center of the X and the Y. And the reason I had to create this was because I can't actually use these components to create a cut, right? I just can't do that. I don't think Fusion will let you, but it wouldn't make sense to do that anyway because I kind of need to have these guys here as a visual reference to know if I have proper clearances and things. So that's why I had to create a standalone sketch to create this cut. So I extruded out. The extrusion is done with the distance for it anyway, is done with the height parameter. So I added a height parameter, so I can always change that if I ever want to increase the height of the case. And that's kind of it. That's really it for that. So the next thing I do is I create another sketch. This time it's being created just on the bottom plane here. So I'm going to go ahead and turn it on now. It's called box. And it's just a box. You'll know it's got kind of the same things that we did in part 1 of the tutorial. So if we go inside of the dimension, it's spacing divided by 2. So that's how we get this this enclosure to be kind of a little bit pushed back this way here. And then the width of the enclosure is spacing times down. And then this one is spacing multiplied by across. And that's how we're able to get the width and the length of this enclosure. And then the distance right here, the spacing, so that it's kind of in the right spot. So that's how that's working. Nothing changed there. The next thing I did was I did an extrusion for the case. And this one's using the height for the distance. So that's parametric. Then we step into this is a little bit different. I think I added this new. This is called an offset. So this offset here is just selecting all these 4 edges here and just bringing it out a little bit more. This is in case you want to have a little bit more distance from the edge of the enclosure to the button. Let's say you just want your hands to rest on these this more margin or padding, whatever you want to call it. There's just this little embedded offset that I think works really well. Then I kind of run through, making the case. So I do a little fillet here, which is also parametric. So if you want to change the fillet, you can make it a little bit more or less, whatever you like. Then I do the shell. Now the shell is actually parametric now as well. So I just typed in shell, and if we bring up our parameters, our user parameters, you can see shell is set to 1.5 right here. And the fillet is set to what, 8.6 over here. So we could change those if we ever want. Cool. Next things we do is we run a subtraction, which is really called a combine, but the type is set to subtraction. So let me hide the parts for a second. So you saw what I did. I subtracted our first circle that we made and subtracted from the box is a cut. So that cut is made, and then I patternize the cut, right? I do a patternize. It's very, very similar. The pattern type is set to faces instead of components like we did for the arcade button component. We have distance set to spacing, quantities across, spacing, down, and spacing. You notice I didn't have to put negative spacing here. So as I built this first and then step backwards to import the components, I did have to put that negative. But for this, I did not have to put negative. You see if I put negative there, it's going up that way. So just kind of keep that in mind, why one has negative and the other one doesn't. And that's pretty much it. Now that's set there. Let's step into the next thing that we did. The next thing we did was we're doing the cover. So this is where we start doing the new stuff. So speaking of new stuff, to create this sketch, all I did, so starting off right here after the patternize was done, all I did is I went to the bottom, I clicked on it, and then I hit the letter P on my keyboard. What does P do? It does this. It does a projection. Projection is kind of making a sketch from a face or surface. So I clicked on the surface / face, and then I hit P on my keyboard, and it created this sketch here. If we look at the sketch itself, it doesn't look like there's much there. There's no kind of visible lines. Because it's a projection, Fusion kind of hides that away. But if you roll over with your cursor, you can still see all the lines that make up the projected sketch. So we have this lip here, and we also have this inner area here, which is actually shelled out. So we have this. So we're going to use this sketch to create our cover, right? The bottom cover of the case. So we don't really have anything extra here. It's just a projection. Now what's important about this is that if we ever change this, so if we put 3x2, you'll notice that it's growing with it. So that's why it's a projected sketch, because it's going to reference the case, this box here. So whenever the box gets updated, this sketch will update with it. So understanding that, now we can actually extrude out that profile. We just select the outer and the inner part, so this area and that area. We select those. As you can see, the profile says 2 selected. And then we do, we're extruding downwards. So it's not up, but it's extruding down, and the Fusion just sees it as a positive value. So 1.5, you can change this to whatever thickness you want, but I have it set to 1.5 to be consistent with the shell. So once that's set up, then I create another sketch. So what I do is I click on this surface, and then I hit P on my keyboard, again, P being project sketch, and now I created a new sketch. This is where I start adding all of the geometry sketches for creating the lip. So I'm going to go inside there now and show you what's in there. So basically what I did was the first thing I did was I created this line here. This line, well, maybe not created first, but the line is just a regular line, but there is a constraint set to it, and the constraint is a midplane. If you look over here, the little triangle, that means midpoint. That means always be in the center of a given edge. So the way you can create it is when you're in the line tool, you just roll over an edge until it shows you that icon, and then you click, and then you drag it down, and then click on the adjacent thing, the adjacent edge over here, and that's how I built that. And then what I did was I clicked on the line, and then I made it into a construction line. So these dotted lines make it so that it doesn't actually intersect. It's being used as a reference point, not an actual intersecting line like these are. So after that, I made some offsets. So I just clicked on I hit O on my keyboard. You could probably find that under Sketch. Offset is somewhere in here. I don't see it, so that's why I like to do this right here. You just type in offset. You can bring up your models, your toolbox anywhere. Just hit the letter S, and wherever your mouse cursor is, that's where it will be. So S, and then I do offset, hit enter, like this, and then I select the outer edge, and then I can bring this inward. What I did though, instead of putting like a fixed value, I actually said shell plus gap. So the shell being 1.5 millimeters, and then plus gap, which is a tolerance thing. When you're making snap fit cases, you want to have a little bit of a clearance from the two mating surfaces. You want to have them have a little bit of distance. So when you're 3D printing something, even when you're CNC milling, you want to have something of a gap. So that's why I have a gap there. Right now, my gap, I believe, is 0.2. Yeah, so we can change it. So if your printer likes a bigger gap, add a bigger gap, and then this will update. So watch this. I'm going to put 0.4, and you'll notice that everything updates here, those two offsets. Let's go back to 0.2, and then take a look at the second offset here. This is shell multiplied by 2 plus gap. So with that, we actually have a lip that we can now extrude. This is the lip for our bottom cover. Now, when you look at how thick this lip is, you can just select this, hold down shift, and select that edge, and then you can get down over here. It says it's a distance of 1.5 millimeters, which happens to be the shell. So that's how I created this. So it's all done with a little bit of parameters and a little bit of math. So that works out there. Now you'll notice something at the bottom here. What is this guy? So this guy is a little rectangle. It's actually a center rectangle. So if I type in center rectangle, you don't make it from corner to corner. You make it from the center. So you click in a point somewhere on your grid, and then you grow it out, and you can see that there's these two extra lines. These are construction lines. It has this kind of built-in construction lines that have a little bit of constraints to them. So they're kind of flexible in a way. They kind of just broke it right there, but whatever. I used that because it just kind of helped out here, because I needed to be able to find a center of this to get this in the exact center. So this is going to be my opening. As long as it's a little bit bigger than the feather, I should be okay. So that's why I made this into a parameter, a user parameter called lip cut, because it's cutting the lip, right? And then the height here is just a little bit of extra here. It's as long as it's thicker than our lip itself, then we should be okay. So that's why now this intersects. This is the part that I don't want, so I just select this area. This lip wraps around the whole case, and we have that area that we don't have to worry about now when intersecting with our feather. So that's how I built that. Cool. And again, it'll always update whenever I change the amount of buttons. So let's say I want 3 across. You'll see that it's the rectangle is moving because it is told, it's constrained to the midpoint, and the midpoint is right over here. Remember we talked about that there. So that's how the midpoint. It's always going to be in the center of this edge here, and the edge here is projected. So it's just this long chain of projections that keep on going and make everything work. So let's get out of that now. Hopefully that was clear. And then once that sketch was done, I extruded just the lip. I gave it a height distance of 3 millimeters because that is the height that I just kind of want this bigger nub. So just make it accordingly depending on how big you want your nub to be. So it's set to join operation, so it's all one now thing. So let's take a look at what we have. We have our box, we have our cover, and we have a lip. if we run a section analysis, I can kind of see inside and take a look at this. So we can test this out. So you can see our shell, we can see our gap, and we can see, I guess, our lip, right? So let's play around a little bit with it. It's really important to test all of our things before we run any further. So I'm gonna play with the shell first. I'm gonna make this 2 millimeters. You notice that everything moved. The gap stayed where it is, but the thing just worked well. Now let's change the gap. Maybe make it, I don't know, maybe 1 extreme. So now you can see the 1 is, nothing's broken yet. We're looking pretty good. All the fillets are there. We could even play with a fillet if we want to. We can make this into 8. And you can see that all that geometry is being maintained. All the projections are being maintained, which is pretty cool. So I'm gonna set this back, put this back to 0.1, 0.2, and put the shell back to 0.5 like that. So it's all working right now. So that's great. So now we can move forward. And again, if we take out the section analysis, we can look for our lip and make sure that it is being cut where it needs to be cut, right? So that cut's still there. And maybe make this back to 2, and you can see the cut updated just fine. So the cut is maintaining its width and its positions, its midpoint constraint position. All right, the next thing I did was I made the side nubs. So I'm gonna work on the nubs for this guy here. So what I did was I basically picked one of these edges, doesn't matter which one, or surface, doesn't matter which one you pick kind of, but I picked this one, select that. That's the inner wall of our enclosure. And then I hit P on my keyboard again for project, under sketch, project, and that makes it into its own sketch. So then what I did was I made yet another construction line, finding the midpoint of this whole rectangle area, and then starting it right there. And then this isn't actually a center rectangle, it's just a regular rectangle. It's just kind of like you make that, and then you assign a width to it. So what I did was I assigned a width here, spacing multiplied by down divided by 2. That spacing and then multiplying by 2, dividing by 2 rather. And this is the width we get, which is 34. And then the height is, make sure it's the same as the height of your lip height that we did for our cover. So it is the same, it is 3 millimeters. So as I update this, let's go ahead and try this out. I'm going to put 3 over here on a cross. That didn't work. I need to put down. So down is 3. So you have to be sure where you are in terms of where is down relative to your sketch. So in this case, it's down. So you can see it's updating. So it's doing what I want it to do. You might ask, like, well, why didn't you go across this whole thing? It's mainly because when I tried doing that, it kind of bowed. So having more friction points on the left and the right here just kind of make the snap fit behave a little bit better. So it's just more of like a manufacturing thing. Like when you print it out, it actually doesn't work if you just do lip all the way around. So the next, you try it out for yourself if you don't think so. But the next thing is kind of figuring out how do I make this nub also be over here. So to do that, I get out of there, and then I make a midpoint here, a mid construction plane. So the mid construction plane is going to allow me to mirror this guy directly in the center. So I'm going to double click on that midpoint, the mid construction point, and I'll show you how I made it. You basically select 2 planes, and then the mid finds the middle of it and makes a construction plane. So you get a new folder called constructions. It's not here yet because I'm modifying it, but there it is. Once you hit OK, there's a construction plane. You can use that to cut a face. You can use it to mirror things. It's to build and construct. So that's why you can do these. These are really, really powerful things. Thing is about this is watch what happens when I add more to the design. So I'm going to put 3 across, and you notice that the mid is parametric. It is always going to be in the center of those 2 faces. As long as those 2 faces exist, I can depend on it updating. So it's updating now. So that's cool. So now what I do is I go ahead and I extrude it out. You'll notice something pretty cool here. I extrude it out, but where are the chamfers? Where are the chamfers? If you go inside the extrusion, you'll notice that I have a tapered angle. This is not hidden, just there. So by default, it'll probably look like that. But if you look at the handler, you can see that there's a little bit of a tape. You can actually flare it out or flare it inward. And that's what I did. So I put -45, and that saves me like 3 steps. I don't have to chamfer out these edges and then the top and the bottom. It all does it for you, which is awesome. The next thing to do is to mirror all of this to this side over here using this guy as my kind of tool. So I run the mirror, I type in S to bring up the toolbox and just type in mirror, hit enter, and then run it. So here's the mirror applied. You can see how it's built. The pattern type is set to faces. I went ahead and selected all the 4 faces, so 2 here, 1 there, and 1 on the side there. And then my mirror plane, I just select that mid plane that we created and talked about. And then I hit OK, and then it applies it. So now we have this mirror that's driven with parameters. So now if I go ahead and test that out, let's say I want 2 by 2. That updates, well, let me update it. 2 by 2, you see the nub has dynamically updated its width, but has retained its position. It's always locked to the top there using a collinear constraint. That's awesome. The next thing I do is I create another sketch. This time it's going to be the indentations. So I actually made this. Every sketch is almost about kind of projected from some other geometry, and that's how the way this thing is driven. So if I bring up back the cover, I basically went in here, clicked on this surface, and hit P to project. That makes this, or actually on this side over here, sorry. Yeah, this side, right? Yeah. So I'm gonna go back into it now. That was a little bit weird. Now I'm into it, and you can see how I built it. It's a lot like the nub. It's very much similar to the nub. It has the exact same thing. Spacing multiplied by down divided by 2. But I added a little bit. You can add a little bit of extra offset if you want. So I put +2 because I want this indentation to be a little bit more open on the left and the right. So that's why I added 2. You don't have to do that depending on your printer or whatever. But that's what I found worked okay. And then I just have another construction line in the center using the mid-plane construction constraint. And then that's kind of it, really. The height is just 3 millimeters like we've been making it before, and that just tends to work out. So if you update the widths, you can see it updates just like the nubs do. So cool. So that's working out. So after that, I think that's all we need to do for the sketch. Then we actually extrude it out. So we're extruding the inset here because we need to have this extra material hill, because if we just cut here first for the indent for those nubs, then we wouldn't have any material here because we would be cutting through this whole thing. So that's why I had to add some extra part here. And then what I do is I do like a little chamfer here on the edges. Unfortunately, you can't add a chamfer. If I were to do this, it kind of does that, and that's not really what I want. So I just chamfer out these 2 edges here, this edge and this edge here. You can go into it and show you exactly which edge. So it's actually not the outer edge, but the inner edge, these guys here, and that just kind of rounds it off there a little bit nicely. It's to accommodate for that taper that we did with the nub. The next thing I do is, this is kind of cool. This is really cool, actually. I make an extrusion using the same indent. So what I did was I basically said, I clicked on that. It's kind of hard to kind of see this. So I just selected that nub that we did, or the indentation part, the little section. And then what I did was I said these to start from object, so you can actually use the same rectangle inside of a sketch and then tell it to go somewhere else, to start from a different thing. So you can select, in this case, I selected this guy over here, this edge here, and now I'm cutting in there. And then I made the distance 3, and then I tapered it inward by a -45. When you do that, you get this here. So this is exactly what we want. If we do a section analysis on it, you can see that this surface has a nice distance between this edge here, and it's about 1.5 millimeters. It's so nice. It also happens to be the same as our shell thickness, so that works really well. So that's how that's working. And now with that kind of complete, we can basically mirror that. So using the same construction plane here, this guy, I just select all these faces, run the mirror, tell it to mirror on this plane, and then I get it on both sides. So that's working out really well. And when I bring back the box, you can see that these are now pretty much good. So if I step inside this analysis here, you can cross-section view it and see that the tolerance is still there. Let's go ahead and test out the tolerances. So I'm going to go increase this to 0.4, and you'll see the tolerance is working out. Let's go ahead and play with the shell. That's working out nicely as well. Maybe put a bigger gap. Look at that giant gap there. That's working out okay. And if I play with the fillet, same thing. It's just going to update accordingly. Awesome. So I'm going to set all this back. 0.3 is fine. Shell 1.5 is fine. Cool. So that's working out well. All right. So now the hard part, not really hard, but the next part is to kind of start thinking about the nubs for the front of the box, because we'll see that the front of the box here isn't made yet, or the back really. These are the sides. This is what I'm calling the sides. The right and the left, the front and the back. If you look at the view cube, that's actually pretty accurate. So my design is kind of using that. So these are indeed the side. The right and the left in my eyes are the sides, and this is the back, and this is the front. So the front is where the feather is going to be. I haven't made the feather yet. We're getting there. So the next thing I do is, let's see, I make a sketch. I don't know which sketch it is. Oh yeah, this is going to be the feather, or actually the standoffs for the feather. Let me step out the main component, because it looks like we completely skipped all this stuff. So right after this was done, right after the mirror was done here, right, just like that, we haven't moved advanced any. What I did was I created a new component. So I right-clicked, new component that was made, turned it into a green component here, and this is going to be, let me turn that on. This is going to be the feather. So this is the component I made. There's nothing in it yet. So then what I did was I hid the box. I clicked on this cover, right? This is the cover body. I clicked on that, and then I hit P, and that made a projected sketch. Because now wherever, this is going to be where the feather lives on this sketch here, on this surface. So whenever this updates, our feather is going to update too. So let's go ahead and jump into that. There's our sketch. I'm going to go into it and just show you it. It looks a little bit complicated. Don't freak out. This is just a bunch of sketch dimensions that are defining this, what's going to be the PCB of the feather. So it has all of the things that make the feather the right dimension. So the dimensions here, the distance between the holes, the hole itself. I also made this into a parameter, the hole, in case we need to expand it or not. It's super easy to do that because there's 4 mounting holes. So it's nice to have them parameters. The distance between that is all set here. So here's the thing. I do have an external body here for all of my feathers. Like here I could have, but the problem is if I were to import that, it's actually going to be stuck over here in this area. You see, because that's where I built it. I built it actually outside of this area here. So I had to remake it inside of the design because you cannot tell something to grow with something that is a component. The only reason why this works for the arcade button as well, because the arcade button, the position of the arcade button is in the exact center. The feather was not that case, so that's why I had to remake the feather here. And then you apply another construction plane with a midpoint so that it's always in the center. Watch what happens when I update the amount of buttons. So let's say across, we want 3. That sketch is moving. All of the stuff that make up the sketch, it's moving. And another reason why it's working so well is because I'm using not a regular rectangle maker, but a center-based rectangle thing. So when you make this, you can have the center be. You can tell the center to be a certain distance away from something. If you're doing a regular rectangle, you have to make some lines and stuff to make the center. I still don't know where the center is of the exact dead center. So that's why I did it. So a really good use case of, hey, I need to use a center-based rectangle, not just a regular rectangle. Hopefully that illustrates a little bit. So then I tell it where to go. It's in the center, but how far of a distance do I need from this edge of the PCB to the edge of the case? So I added a little bit of math here. This is shell multiplied by 2 plus gap multiplied by 2. And that seemed to work out well. So you can increase this or decrease this as you want. It's important to have this distance be parametric because if you update the shell, if you update the gap, your feather needs to update too. So watch what happens when I do that. So I'm going to change the gap to like 5. Maybe that's way too much, but I did it and it didn't break. That's phenomenal, it didn't break. But you can see here that my gap is really the tolerance play that I have here. And that's working out. Even the distance, even the shells is working with it. So it's very important to kind of have that built in. So you're gonna have to figure that whatever math it is. You have to figure that. What am I changing? Oh yeah, the shell back to 1.5. Cool. All right, so that's back there, and that's how this is driven. So just building that main sketch that will build our feather into this guy. It's projected from this bottom surface here, or this top surface of the bottom cover. All right, so there's our sketch. We haven't extruded anything, so then I extrude it out. That is the next thing. You notice here that the extrusion is done with an offset. So if we go into the extrusion, you can see that I have an offset from the plane offset from the plane rather. That's where the starting position is. And then the offset is an amount of 3. And then the thickness, or the distance in this case, is 1.6 because the feather in most PCBs have a thickness of 1.6. So that's why that's that. Cool. So hit cancel. So now we have that. And if we test it out, I'm just going to keep testing it over and over again. So you can see that when I change the across, the feather's updating. So everything is locked to it. So that's great. Next thing I did was I just kind of build it out. So I make the fillet out the edges, and then I add the USB port. Then I use this guy here, which is the JST connector. And that's kind of it, really. That's all I need for the feather. I don't need any extra stuff. I don't need the pinholes or anything. It doesn't matter in this design. Just the things that matter the most are the USB port and the JST port, the JST and the USB port. Sorry. Now it's probably important to note that the way these are built is with, again, click on the surface, hit the letter P, and then you get your projected sketch. Right? A lot of projected sketches in here. I'll have to reiterate that over and over again. But it's very important because if they were just kind of made not projected sketch, these would just stay there and not move with the feather. So they're all driven from, like, everything is just linked down this chain of projections. It's crazy. The next things I do is I jump out of the feather component. I jump out of there and go back into the case. And now you can see that I create a new sketch. This is going to be the standoff. So basically what I did was I selected this surface here of the cover, and then I created the sketch. So I hit P on the keyboard, created a new sketch. Let's see what's in there. There's actually mounting holes are in here. So what I did was with the feather not activated but turned on, remember that the case is activated, be sure that's activated, you have to project in these edges here. So you can select these edges and then hit the letter P on your keyboard. Not that, just this edge. You don't have to do that whole thing, just one of these edges here. So do that 4 times, and then you get these pink circles. You can see when you go down, when you look at it from a down view, you can see that they're actually on the surface here. So that's what we want. Next things I'm going to hide the feather now. Next things I did was I just offsetted those circles to create kind of my standoffs. So now I have these little profiles I can select and extrude, which is exactly what I did. I extruded those out like that. I didn't apply a height. I actually told it to go dynamically to the bottom of the feather. So you can say extent to object instead of distance. That's default. Distance is default. I changed it to to object. And then my selection was just selecting. You can see it's blue. It's the bottom of the feather board. So that's why it knows. So if I ever change the feather board, if I want it to be a little bit more off from that, I want more distance, this will automatically update because it's always looking for that feather. And then just make sure your chain faces are set to extend faces. And now you got that. So if I bring back the feather, you can see how the standoffs are, how the feather is resting right on top of those standoffs, because we're going to use screws to keep this thing together. Cool. You could also make nubs if you want. It's up to you. So now that we have that, we can test it out again, yet again, testing it out. And it's going to work, hopefully. Yep, it works. So things are updating. Awesome. All right, what did you do next? I made another sketch. We're not done yet. I got to make the pole for the USB port. So what I did here is this is the surface of the case that needs to have a punch hole. It needs to have a hole so I can connect the USB port. And so I click on that, hit the letter P, and I get my sketch. What's inside the sketch? Yet another midpoint selection. There's so many of these. It's crazy. So again, I turned it into a construction plane. It's a midpoint. That's the constraint to it. And then I built yet another center rectangle, and it's driven not really parametrically that much, other than just the midpoint. So whenever this enclosure extends or moves this way, it'll always be there because it's projected from the sketch. So that's it. There's just this static height and width, really. So 8.5 and 11.6. Just kind of measure out your biggest USB cable. That was my biggest USB cable, so I made sure to have it kind of centered with the actual USB port. So that's why it's a little bit big. All right, then I actually cut it inward. I do some fillets and some chamfers to make it look pretty a little bit. So there you go. You can still see that we have a gap here, which is great for our nubs. All right, once that's done, now we got to start working on those nubs for the front and the back. So that's these guys. So I'm going to hide the box now. You can see that we need to add indents for that. And then the box here, we need to add nubs here. So I select that face, hit the letter P, and I get my sketch here. Let's go inside of it. You can tell that I projected it because there's a bunch of pink lines and those just reference things. So here's the cool thing. Since it's so symmetrical, I only had to build one of these side nubs and then basically mirror it from within the sketch. So you can mirror inside a sketch and outside of a sketch using faces or whatever. So to build this, all I did was I used the regular rectangle tool, started from there and drew it out. I didn't apply any width to it. So there's no width here. It doesn't need a width because all I'm saying is this edge needs to be a certain distance from this edge. Where did this edge come from? This edge was projected in from the bottom cover. If we look at the bottom cover, you can see that the line here is where I projected it from. I projected it from one of these edges here that start the lip cut opening. So I just project that sketch in, and now whenever this updates, this sketch will say, well, I need to be 3 millimeters away from that. So I apply it there, and then I also apply it here. So this is where the end of the fillet is. So if you ever increase the fillet, this line is gonna move. So it's important that it's projected sketch because now it'll shrink depending on the fillet. Let's go ahead and test that out. So I'm gonna go ahead and update the fillet. I'm gonna make it 8, and watch. Keep your eye on the 3 here, right here where my mouse is. I'm gonna hit enter, and you'll notice that it updated. It's actually getting it's shrinking because the fillet. It's just that's the way the fillet works. It just it needs more material to curve. So I'm going to set that back to 6 so you can get to see it again. You see how no matter how this changes, whether you're changing the shell, the gap, the fillet, this guy will always be 3 millimeters away from that edge. Same thing going here. So once that's built, I can add another construction line with a midpoint constraint, and then I just mirror that over here on this side. So now that that sketch is done, I can start extruding it out. So this is actually for the box here, not the cover. So I extruded it out. I just selected the 2 rectangles that we made, and then again following the same distance and following the taper angle of the -45 degrees, and that gives me that nice chamfered tapered edge. So I got those 2 nubs. So now that the nubs are done for that, I need to make yet another midpoint. What is this called? A mid plane. Yeah, the mid plane. So again, I already have a mid plane, but it's going on the opposite direction. It's going from this to this side. This new one that I just made goes from this side and to this side. Again, if this ever gets updated, the mid plane is just going to update along with it. So once I have that, once I have my tool, I can go ahead and mirror those 2 nubs here. So you see these nubs. I selected all that stuff, and then it got mirrored here in the back here using this mid plane as a tool to mirror it. So that's how it's being told to where to mirror, precisely in the center. All right, I'm almost done. So now that I have those nubs all across the enclosure here, I just need to do it to the cover. So here's the cover. I basically use the same this same sketch. We could just reuse it. So that's what I did. I said from object, start from this area over here, starting from that area, extrude inwards at 1.5 millimeters. I could have said shell, which I probably should have done. So we don't have to do that now, but we could probably add shell in there because that is what the shell parameter value is. And that's it. It join the body, and we join it. All we got to do is the chamfer here. So there's a chamfer. And now all we got to do is do the exact same thing, but then starting from this area, and then going inward. You'll see how there's a little bit of gap there. So you have to make sure to select the right edge. So you select the right edge, Make sure you do that inset, the taper angle of -45, and the distance is at 2. So that works out, and that's it. All that's left to do is to select all those faces and run a mirror command using the same midplane here. So now I have it in the back there. So that works out. And that's kind of it. So if we go back out to the main component, you see that's the very last step, was to just do that mirror in the back there, so that we have it in the back. Now we have it in the front. So that's it. Lots of projections, a couple of construction planes, so many midpoint constraints. We have all of our arcade buttons are still there. I have a nice parts component that I can hide and show and hide. Yeah, hopefully that wasn't too, I don't know, too complicated or whatever. It did take me quite a minute to figure that out, but it's definitely a great exercise in how many parameters can I make. There's quite a bit of them. Maybe you don't need them all, but they're there. So 4 by 2, this works out well. To break it, you really have to put 1 by 1 would absolutely break this design. So here's what it looks like. Wait. Yeah, you can see the feathers poking out there, and the standoffs are coming out. I don't have any errors. Normally you would get errors and say like, hey, there's a missing surface or something, but somehow it's working okay. It just made these into separate bodies, I think. Or no, maybe it didn't. That's crazy. But you can see that obviously wouldn't work. But if you wanted to, you could probably just add more offset. So watch this. I'm going to put offset here. I'm going to put like 15, and then maybe that will give me an offset. Oh, look at that. So now I have 1 by 1 button. It's not breaking because I have, see, this is why it was really important to have that offset. I'm glad I added that in there. So I'm going to put this back to 2 by 2 and show you how the offset kind of makes it nice. It just adds that extra padding all around the box. So it's got that nice padding. So I'm going to change the offset now. I don't know what it was, 7 or something. I'm just going to close the design and not. So I'm going to share this with you guys. You could look in the description. I think this is pretty good to go. I've tested this out quite a bit. Again, if you are 3D printing on a different printer, different nozzle, different filament diameter, different slicer, you will need to change the gap depending on your thing. If you ever printed something with a snap fit thing before and you know what a good tolerances is, go ahead and modify it as you need to. But for me, mine's usually 0.2 or 0.3. On the Ultimaker, I tend to put 0.3. For the Flash Forge, I tend to put 0.2. So that's why I have it built in there. I think moving forward, I'm definitely going to apply these techniques to if the project calls for it. I know now I have a reference project of where I can do this. Obviously, there's other things you could do. You could add a battery. There's no battery here. There's no power boost here. There's no extra boards. It's just a single board and just a couple of buttons. So although it's simple in that case, it was actually quite a journey to develop something that doesn't break when it's driven with all parameters and projected sketches. So hopefully that was digestible. Let me know what you guys think. If you think I could shrink this down in terms of the timeline, if you think I could accomplish this with less steps, let me know. If you think a sweeping thing would work better, like if I just swept this along, I'll have to reiterate that did not work for me. That's what I tried at first. I just had this nub sweep across this entire thing. But when I printed it, when it scales large, you actually it like no longer works. It's a very strange thing. I'll have to share it on one of the 3D Hangout shows. How as you scale this design, it's actually better that you have more points of friction. So that's why this isn't just all swept one giant nub and one giant lip inset thing. So just thought I'd throw that out there. I did try it and it didn't work. So I would love to know any alternatives, but this is maybe it's overcomplicating it. I would love to simplify this even more. Thank you guys so much for watching. That is going to be it from me. I will see you guys next week. Bye, everybody.